In this video, you will learn how to prove that lines are parallel. First, let's review the term converse. The converse of a conditional statement switches the hypothesis and the conclusion. So if the hypothesis or the first part of the statement is P, in the converse, it becomes the second part of your if-then statement. And similarly, the conclusion is the second part of the if-then, it becomes the first part. So if two lines do not intersect, then they are parallel. The converse, which is the order, so I say if two lines are parallel, then they do not intersect. So for example, the first one says if an animal is a cat, so is a cat is our hypothesis, then it has four paws. So for the converse, we would switch the order. So the statement would be if an animal has four paws, then it is a cat. For the next one, the original statement says if two angles are congruent, then they have the same measure. So for the converse, I switch the order. So if two angles have the same measure, then they are congruent. And lastly, it says if a squared equals 25, then a equals 5. So the converse would state that if a equals 5, then a squared equals 25. Now let's review the theorems we can use to prove that lines are parallel. So the first theorem is the converse of the corresponding angles postulate, and it says if two lines in a transversal form corresponding angles that are congruent, then the two lines are parallel. So for example, if angle 1 and angle 2 are congruent, then L is parallel to M. The important thing is you remember that we use the converse term when we refer to this theorem. Similarly, the converse of the alternate interior angles theorem says that if two lines in a transversal form alternate interior angles that are congruent, then the two are parallel. So if angle 1 and angle 2 are congruent, then the lines are parallel. And the converse of the alternate exterior angle says if two lines in a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So if angle 1 and angle 2 are congruent, then the lines are parallel. The last two theorems says the converse of the same side interior angles theorem. So if two lines in transversal form same side interior angles that are supplementary, so they add to that 180, then the lines are parallel. So if angle 2 and angle 4 are supplementary, then L is parallel to M. And for the converse of the same side exterior angles theorem, if two lines in transversal form same side exterior angles that are supplementary, then the two lines are parallel. So if angle 1 and angle 3 are supplementary, then they're parallel. The important thing that we remember here is that whenever we're referring to any of these theorems, we always use the term converse to indicate it's proving that they are parallel. So in the following examples, we'll go over how you can identify which lines are parallel and the reason that you use for each. First, let's kind of visually see what we have in the diagram. So for my first angle right here, I usually like to trace over the sides just to see what I have. So I have one side of the angle right here and here. The other angle that's given is this angle right here, and it has these two as the sides. Now we can see that the lines that are going to overlap is this line right here. So this is what becomes my transversal, where they run into each other, which means that the other two lines have to be the parallel lines. So I could say that line BE is parallel to line CG, and your reason would be that since these are corresponding angles, it would be converse of corresponding angles. Again, if you don't have the term converse there, your answer is technically wrong. Again, if I start by tracing over my angles, one angle is right here, and these are the sides. The other angle of 45 is here, and these are the sides. The line that runs into each other is this line right here, so this becomes my transversal, which means that the other two lines are the parallel lines. So I could say that line or segment CA is parallel to segment HR, and again, these are corresponding, so my reason would be converse of corresponding angles. The next example I have, I'm talking about angle J and angle L at 180. However, if I look at just angle J, it has the sides of these angles, and angle L is right here, and these are the sides of this angle. Now we can see that one that runs into each other is this segment here. So this becomes my transversal, which means that these would become my parallel lines. So this means I could say that segment JO is parallel to segment LM, and our reason is these are same side interior, and we know same side interior should add to 180, which we have. So my reason would be converse of same side interior angles. Again, I'm going to start by tracing over my angles. I have angle P, which has these as the sides, and angle Q with these as the sides. So the one that runs into each other is the transversal here, which means that my parallel lines are PQ and ST. So I could say that segment PQ is parallel to segment ST, and our reason would be these are congruent, and we can see these are alternate interior angles. So be converse of alternate interior angles. The next one says, which lines, if any, must be parallel if angle 1 is congruent to angle 2 and justify with the theorem or postulate? So if I have angle 1 is one of my angles of right here, and angle 2 is the other angle right here, we can see that the one that's going to be our transversal is this side right here. So my parallel lines are these two lines. So as a result, I could say that DE is parallel to line CK, and those are alternate interior angles. So I could say converse of alternate interior angles. For the next, I'm going to start by erasing everything and trace over my angles again. So I have angle 3 and angle 4. Now I have angle 3, which has these sides, and angle 4, which has these sides. My transversal again becomes where they run into each other. So the other sides of the angles are the parallel lines. So I could say that line EC is parallel to line DK, and our reason would be converse of corresponding angles. For the next one, it says find the value of x for which L is parallel to M. So if we see what we have here, these are my two angles, and these two angles are corresponding angles. So in order for them to be parallel, we need the angles to be congruent. So if I set 40 equal to 2x plus 6 and I solve, I get 34 equals 2x, and 17 equals x. And if I were to plug this 17 back in, it would give me an answer of 40. So the value of x that makes them parallel is 17. For the next one, the two angles I have are the 7x minus 8 and the 62. Now these angles are same side interior angles, so we want them to be supplementary. So if I have 7x minus 8 plus 62 equals 180, I can solve. So 62 minus 8 gives me that 7x plus 54 equals 180. So I get 7x equals 126, and I divide by 7 to get that x is equal to 18. Now to check our answer, we can plug the angles back in. So if I plug in 7 times 18 minus 8, it gives me a measure of 118. And if I combine the 118 and the 62, it gives you 180. So your answer is correct. For the next one, the angles should be corresponding. So we want them to be congruent. So I could say 55 equals x plus 25 to get 30 equals x would give us the angles are congruent. For this problem, I have two angles that are alternate interior angles, which means we also want them to be congruent. So I can say 95 should equal 2x minus 5. So if I solve, I get 100 equals 2x, so 50 equals x. It would give us that the lines are parallel. For the next one, I have two angles that are alternate exterior angles. So in order for them to be parallel, the angles need to be congruent. So I could say 3x minus 33 should equal 2x plus 26. So if I solve, I get x minus 33 equals 26. So x is equal to 59. For the next one, we need to make sure that we're focusing on just the angles that are given. So I have one angle is this 105 is given right here. And the other angle is this angle right here, which has these sides. Now, the transversal we have is this angle right here. However, when I look at what the parallel lines are, we have lines that we want to be parallel. However, we don't have a direct relationship. But if we know that these lines are parallel, I can say that this angle is also 105 because these are corresponding angles. And then from here, I could actually write an equation to solve. So I could say this whole thing should add to 180. So 105 plus 3x minus 18 should equal 180. So if I were to solve this, I'd have 105 minus 18, which would give you 3x plus 87 equals 180. So I have 180 minus 87 gives you 93. So this means that we would want x to equal 31. For the next couple, we're using a slightly more complicated diagram to see what the relationships are. So if I have angle 2 with these sides and angle 3 with these sides, this means the transversal is this line right here. So the parallel lines would be these lines. So for number 10, I could say that A is parallel to B by the converse of same side interior angles. For the next one, I'm going to start by erasing on my diagram. So I'm now looking at how angle 6 and angle 7 are related. So angle 6 is this angle right here, and angle 7 is this angle here. And I can see that this becomes my transversal, so these would be my parallel lines. So for number 11, I could say that A is parallel to B by the converse of same side interior angles. The next one tells us that angle 1 and angle 4 are supplementary. So for this one, I have this angle 1 is out here, and angle 4, and I can see that the lines that run into each other as my transversal are right here. So my parallel lines would be these two lines. So for number 12, I could say that A is parallel to B by the converse of same side exterior angles. And for my last one, I have angle 7 is 70, and angle 9 is 110. Now this is a different one because if I look, angle 70 has these sides right here, and the 110 degree angle has these sides. Now if I were to cross these completely, they don't have a line that runs into each other. They're two totally separate lines. So as a result, you can't actually make any conclusions because I don't have a transversal. So as our answer for 13, your answer would be none or no conclusion because there's no transversal. For the first example here, I have angle 1 and angle 3. And I can see the lines that run into each other to form our transversal is this line right here. So my parallel lines are A and B. So I can say A is parallel to B by converse of corresponding angles. For the next one, I have angle 3 and angle 6. So angle 3 is this angle here, and angle 6 is this angle here. So my transversal is this line. So my parallel lines would be A and B. So you could say A is parallel to B by converse of alternate interior angles. And for my last one, I have angle 1 and angle 8. So my transversal becomes this line, and my parallel lines are A and B. So you could say A is parallel to B by converse of alternate exterior angles. For the next one, I have angle 9, which is formed by these lines here, and angle 12 formed by these lines. Now, what we should see is these are vertical angles, so you can't prove any lines parallel because it's only one set of lines that we're dealing with here. So your answer would be none. For the next one, we have angle 2 over here and angle 10 right here. So my transversal would be the line that crosses, and my parallel lines are these two lines. So you can say that L is parallel to M by converse of corresponding angles. And for the last one, I have angle 8 and angle 6. So my transversal would be this line L, and my parallel lines are A and B. So you say that A is parallel to B by converse of corresponding angles. Now, before we go into the next part, just to briefly review, in order to say the two lines are parallel, it means we have two lines that continue in the same direction forever. We use the little arrows to indicate that they're parallel, and you write these lines in between. So let's say we have A and B. This means A is parallel to B. Similarly, if we have perpendicular, this means you have two lines that intersect to form a right angle. And what we use is an upside down T to indicate it. So let's say A upside down T to B. This means A is perpendicular to B. Now we're going to review a couple of different theorems relating to this, and then we'll talk about what the examples are going to look like. So if two lines are parallel to the same line, then they're parallel to each other. So if A is parallel to C and B is parallel to C, then A is parallel to B. Similarly, if two lines are perpendicular to the same line, then they are parallel to each other. So if M is perpendicular to T and N is perpendicular to T, then M is parallel to N. And lastly, if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other. So if L is parallel to M and L is perpendicular to N, then M is perpendicular to N. Now, what the examples like this are going to look like is you're basically going to draw a diagram for what's given. So for this one, I'm going to draw A is parallel to B, and your diagram may vary from what mine is, but your relationship should end up being the same. But so if I have line A and line B, and they're parallel, so I drew this one. Now I need to draw on line C that is also parallel to this. So I'm going to draw on line C, so it's also parallel. Then I need to add line D, which is also parallel. Now what the question is asking us is what is the relationship between A and D? What we can see is this is line A and this is line D, and these two lines are parallel. So we say that A is parallel to D as your final answer. For the next one, I again start by drawing a diagram. So I have line A and line B, and they're parallel to one another. And then I add in line C that's parallel to B. So I have line C is parallel to B. The next one says that C is perpendicular to D. So I'm going to draw a line D in the other direction, and it's perpendicular. So this forms a right angle, which means as a result, these are also right angles. Now, if I want to see the relationship between A and D, this is line A, this is line D, we can see that A is perpendicular to D. For the next one, I start with line A and line B are parallel. Then I have B is perpendicular to C, so I'm going to draw on line C and make it perpendicular. So these are right angles. Then if C is going to be parallel to D, this means it's parallel to this vertical line. So line D goes here. These two lines are parallel, which means that these are right angles. Now the relationship we want is between A and D, and we can see that A and D have this perpendicular relationship. So I would say A is perpendicular to D. Then I have line A and line B are perpendicular. So this is the right angle. Then it says that line B is parallel to C. So C goes in the same direction as B, forms a right angle, and these are parallel. Then C is parallel to D, so C goes the same direction as D, parallel, and forms a right angle. So I could say that A and D have these opposite directions, so A is perpendicular to D. Then I have line A and line B are parallel. Line C is perpendicular to B, so C is going to go in the opposite direction and form right angles. And then C is perpendicular to D, so D goes in the opposite direction of C, so D would go in this direction. It forms a right angle and is parallel to the original lines. So I could say that based on this drawing, A is parallel to D. Next I have A is perpendicular to B. Then B is parallel to C, so C is also vertical, forms a right angle, and they're parallel. And C is perpendicular to D, so D goes in the other direction. Making these lines parallel because these are also right angles. And again, I want to look at how A and D are related, so I could say that A is parallel to D. Next I have line A and line B are perpendicular. Then B is perpendicular to C, so C goes in the opposite direction of D and forms a perpendicular angle of B and is parallel to A. Then C is parallel to D, so D also goes in the same direction as C, is also parallel, and forms a right angle. So if I look at how A and D are related, I could say that A is parallel to D. And for my last example, I have A is perpendicular to B. So this is A, this is B, and they form a right angle. Now B is perpendicular to C, so C goes in the opposite direction of B. So it forms a right angle and ends up being parallel to A. And then D is perpendicular to C, so D goes in the opposite direction of C. So these are right angles, and B and D are parallel to one another. Now if I'm looking, I want to see how A and D are related. You can see they go in those opposite directions, so A is perpendicular to D.